Most of us walk into a newly built house, see the fresh paint, the shiny countertops, and assume it's a modern marvel of construction. We figure the builders use the best practices available. But the reality is very different. This diagram shows a basic performance scale for construction. When a home is built to code, it isn't hitting premium or even standard marks. The needle drops all the way down, resting right on a red line at the bottom. That line is the lowest legal limit of safety and quality allowed by law. It's a structure designed simply to pass a basic inspection. That bare minimum standard is exactly why you end up dealing with rooms that are freezing in the winter and boiling in the summer. It's the reason your utility bills spike unpredictably, and why you feel cold drafts creeping in around the windows. We are going to reject that industry obsession with slapping houses together as fast as possible. Instead, we are going to treat a home like a carefully engineered, tightly sealed machine. We have to design for the real world, because nature is punishing. The structures we build must stand strong against brutal summer heat waves and lock in warmth during deep freeze winters without breaking a sweat. That means our goal isn't to build to code. We are going to overbuild. We are creating a structure designed with such care and precision that it will easily last a century. To do this, we follow a few core rules. The first is that we prioritize physical engineering over chemical solutions. Most standard builders reach for temporary chemicals like caulk, tape, or glue to keep wind and rain out of a house. But chemicals dry out. They eventually crack. Over time, they inevitably fail, and water finds a way inside. This diagram shows a better way. Instead of glue, we use gravity. By mechanically overlapping our building materials, like the scales on a pine cone, water hitting the wall is forced to slide harmlessly downward and away from the structure. That brings us to our second rule, creating a continuous boundary. This diagram illustrates a cross-section of our house. We want the home's protective layers, the thick insulation and the barriers that keep out wind and water, to act like a single, unbroken balloon tightly hugging the living space. And that balloon has to stretch flawlessly around everything. It runs all the way down below the dirt to wrap the bottom of the foundation, and it extends all the way up to seal the very peak of the roof. If you leave even a tiny gap in that boundary, the weather will find it. A single weak point compromises the entire thermal and weatherproof system, letting your expensive heat escape and allowing moisture to sneak inside. Because everything is tied together, our third rule is that we must treat this tightly sealed house as a single interconnected machine. Think about it. If we make a house perfectly airtight so we never lose energy, we create a new problem. The home can no longer breathe through all those accidental gaps and cracks that old drafty houses have. This visualization shows the solution. The house needs mechanical lungs. We install engineered ventilation systems that constantly swap the air. It pulls out stale indoor air and carefully pushes fresh, filtered air from outside in, ensuring the indoor environment stays healthy. So how do we put this machine together? We start deep in the earth, building a subsurface fortress that completely ignores freezing ground temperatures and blocks out soil moisture. Next, we erect the bones of the house. We build an armored structural skeleton and wrap it tightly in thick, continuous layers of insulation. That the shell's secure, we run the home's vascular network. We route high-efficiency plumbing and airflow systems right through the protected center of the building. Finally, we apply a strong exterior shield. This outer layer acts as an umbrella that aggressively sheds heavy snow, pouring rain, and fierce winds before they touch our airtight balloon. Because the house is one giant machine, altering any single part of that anatomy sets off a chain reaction across the entire structure. That is why every layer requires absolute precision from the very start. This brings us to the final and perhaps most important rule of our building process: trust, but verify. When you are building a home like this, you do not simply nod and accept a contractor's word that a job was done correctly. Instead, we use applied math and physics to absolutely prove the house performs exactly the way we designed it to. We demand hard evidence before the final check is written. To get that proof, we use specific scientific tools. We pressurize the house with massive fans to check for tiny air leaks. We use airflow hoods to measure the ventilation. And as you can see in this thermal image, special cameras used in the dead of winter guarantee absolutely zero heat escapes through the walls. Achieving this level of quality requires a major shift in how you think. You have to care deeply about the tiny hidden details that will eventually be completely covered up by drywall. An overbuilt home is an investment in legacy engineering. It is a protective, highly resilient machine meant to safely shelter a family for generations. If you are ready to learn more about the science of high-performance living, please like this video and subscribe to the channel.